Everyone, and welcome to our lecture on branching. This is one of my favorite chapters in an introductory programming course because it's where I feel like the content starts to get exciting. With branching, we can start making decisions which lead to different paths in the program. So let's go ahead and jump on in and start looking at the content. So what is branching? Well, branching allows programs to execute different statements depending on a condition. So basically, we'll have a condition, something that evaluates the true or false. And based on that, we'll make a decision and we'll flow in one direction or the other. If you remember back in our initial lecture, we talked about Dr. Sheldon Cooper's friendship algorithm, and there was some diamonds in there. So the diamonds were the ones that we had two paths coming out of, one for yes and one for no. So that's with flowchart syntax. In Python, though, we have to use if statements. So if something is true, then we'll do something. And then optionally, we can have an else statement, which means when that something is false, we can do something in the else statement instead. Now, here's where indentation starts to matter. I had mentioned in our initial lectures that Python enforces whitespace, and this is part of that. The indentation shows what belongs to the if and what belongs to the else. And we'll see some examples of that, and it's a pretty easy concept to understand. PEP 8, the Python Enhancement Proposal number 8, is some guidelines or conventions that Python programmers follow. And it says that when we indent, instead of using tab or an arbitrary number of spaces, we should just use 4 spaces for indentation. So that's what I'm going to use, and that's what I encourage you to use as well. Because if you start mixing tabs and spaces or different numbers of spaces, Python's not going to be able to interpret that correctly, and it's going to crash when it's running your program. So, looking at the sort of abstract syntax here, if an expression, so this expression will be something that evaluates the true or false, then we'll do the statements that we want to do if that expression is true. So notice this has been indented underneath the if block, 4 spaces, and we could put as many statements as we want in here. Print something, do some math, call some functions, whatever it is we want to do. And then optionally, we can have this else block, which is just the keyword else followed by a colon. And then underneath it has a block, so 4 spaces, and then all of the statements that we want to do when we take that path. Now, once we're done with either one of these paths, we have to dedent back to where the if started. And that's when we'll carry on with the rest of our program. So why don't we take a look at an example, and I think some of this will make a lot more sense. So, in this example, the local movie theater gives a 20% discount to children under 13 years old. Write a program to prompt a user for his or her age and output his or her discount based on the inputted age. So before we jump into Python code, I want to take a brief look at a flowchart because I think this helps visualize what's going on very well. So we start here, we end here. As we know, we've progressed through programs from top down. Okay, so we have an input here is what this symbol means, and we're asking for the age, and then we're going into a diamond. So not the best looking diamond, but that's what this is supposed to represent. And we're saying is age less than 13. If it is, then we'll take the yes path and we'll set the discount to 0.2 for 20%. And if it's not, then we'll set the discount to 0 for 0%. Now notice these two lines meet back up, these paths. And when they meet back up, that's when we're carrying on with our program right here on line 6. And we'll just print out your discount is whatever the discount is. Okay, so doesn't matter which path we take, we're going to assign something to discount and then we'll print it out. Well, let's turn this flowchart into Python code. Okay, so let's walk through it one step at a time. following the same thing here. Line 1, age equals input age. And since we're going to be comparing age to something, another number, we need for that age to be an integer. So that's why this input's wrapped in int. Then we immediately go into our diamond, our if statement. If the age is less than 13, colon, notice that we've indented 4 times to show the body of our if statement, discount equals 0.2. Now, when I'm done with the body of the if statement, I'm going to dedent back to the same indentation level that the if was on. And in this case, we want to have an else, so we'll use the else keyword followed by a colon. And then the next line is another indented body showing what to do in the else block. So discount equals 0. Now, when we're done taking our diverging paths here, we'll converge back on line 8. Notice it's on the same indentation level as the else and the if. So that's how you know that we've left the else block or we've left the if block, because they're not indented the same. So on line 8, we'll just print your discount is whatever the discount is. And let's run through that. It's a quick example. Okay, so we'll get a new script file going, and let's save this in our workspace under chapter 3. Oops. We'll call this movie1.py. Okay. So we got our shebang at the top. We're going to prompt for our age that we know needs to be converted to an input. We'll say if age is less than 13. Now notice this is one of the nice features of an IDE in that after I press enter, after typing this colon, it goes ahead and it indents for me. Alright, so if we were just using a regular text editor, it wouldn't do that, and we would have to put the spaces in ourselves. If that's the case, then the discount is 0.2, else the discount is 0, and then we'll converge back here on the same indentation level and print out your discount is discount. Awesome. So let's run this and see if we can take both paths. So if our age is less than 13, we'll get a 20% discount. So let's try 8. Awesome. And let's run it again. And let's try a large number like 65, and we see that that's 0. So as you're writing your programs, it's good to go ahead and run them in idle and try them with different values and make sure that you're getting what you expect. And if we wanted to, we would exhaustively test this. We would make sure that 13, we would try 13 as an age and make sure that its discount was 0. And we would try 12 and make sure it was 20, and then we'd try an arbitrarily low number like 8 and a high one like 65, just to make sure that all of our bases are covered and that we can feel confident that we have the right logic implemented in our program. Okay. So that brings us to some new operators. You may have noticed I used the age less than 13. Well, that is a relational operator. It returns true or false based on the relation between two operands, the things on either side. In our case, age and 13. So relational operators are very simple. We've been using these for a long time. I'm not even sure when we start learning about relational operators, but very early in life we talk about less than and less than or equal to, greater than or equal to. And then we also have some equality operators. So we can check to see if two things are equal to each other or if they're not equal to each other. So what do these operators look like? Well, pretty much what you think. Less than is the little gator mouth eating the right hand side, and greater than is the gator mouth eating the left hand side. One thing we can't do that's a little bit different than math is we can't put a bar underneath the less than or greater than sign. So when we use operations like less than or equal to, we use the less than operator followed by an equal sign. And the opposite of that's true for the greater than or equal to. We use the greater than operator followed by the equal sign. And to check for equality, it's actually not an equal sign. I should update this slide. Uh, it's actually double equal signs. So two equal signs helps us to differentiate between a assignment statement and an equality check. And it looks like actually they got it right over here, so it's probably just a typo in the slide, but I'll get that updated. Lastly, we have not equals to. So the exclamation point, we could think of that as a not. Lots of times the exclamation point in other languages will negate something or take the opposite of it. So this is not equals. Notice when we write not equals, we don't use double equal signs because it's not, there's no ambiguity there with an assignment statement if we have an exclamation point in front of it. So let's look at some other examples of this. Let's say that we are writing a program to inspect grades. Well, a grade, what kind of data type can we expect a grade to be? Sometimes whole numbers, sometimes floats. We could always play it safe and just do it as a float, so that's what I did here. And put a grade, converted it to a float, and assigned it to the grade variable. And then I'm checking to see did they get a 100. So if grade equals 100, if these two things are equal, then go into the body of this if statement and do this print. You got a perfect score. Now, if the grade is not 100, it's just not going to go in here, and it's going to skip right over this line and keep going. And then it's going to hit this if statement. If grade is greater than or equal to 90, if that's the case, then print you got an A. Else, so any other case, so let's assume that grade is 89 or lower, then it's going to jump directly to this else block and print out you scored less than an A. So if we go through some test runs of that, we can see I put in 100 here, and I see you got a perfect score, you got an A. So why did that do two prints? Well, it came in here and it matched this case right here, and it went into the block and printed out you got a perfect score. 100 is also greater than or equal to 90, so we also printed out that you got an A. Something we're going to want to keep in mind as we're writing our programs. Maybe we didn't intend to do two print statements. Maybe we only wanted one, and we'll see later on how we can address an issue like that. In the second example, we entered 89, and we see that it skipped over the first one. It didn't match the true case for this, so it went to the else block and printed out you scored less than an A. Now, sometimes there's more than one branch we want to take. Maybe there's multiple alternatives, and this is actually what I was just alluding to on the last slide, in that maybe we only wanted one output statement instead of two in the case that someone got a 100. In those cases, there's one other keyword that we need to learn here, and that's the elif keyword, which stands for else if. So when we use the elif keyword, it is optional, and only one branch out of the if, elif, else, or however many elifs we have are actually going to execute. So let's take a look at the syntax, and then we'll look at an example of that. So here's the syntax for elif statements. Keep in mind, elif is optional, else is optional. Neither one of these have to be here, and there's no limit on the number of elif statements that you can have. Okay, so the thing to take away is we have an if. An if can be associated with multiple elifs, and it can also be associated with 0 or 1 else blocks. And no matter what, only one of these conditions is going to execute. So if this condition is true, then it's going to jump in here and do this body. If it's false, then it's going to come down here and check this condition. If this condition's true, then it'll jump in this body, and when it's done, it's going to leave and come right back down here to line 11. Don't ask why there's a greater than sign there. That should not be there. Okay, if the condition on line 3 is false, then it's going to skip on down to the next condition. It's going to check that. And if that's false, it'll check condition 4. If condition 4 is false, then and only then will it jump to the else block. Okay, so else, we only go into this block if all of the other conditions are false. All right, so let's extend our movie example a little bit. The local movie theater gives a 20% discount to children under 13 years old. They also want to give a 25% discount to senior citizens age 65 or older. Write a program to prompt a user for his or her age and output his or her discount based on the inputted age. So, we have our original program where someone under 13 gets a 20% discount, but now we're adding on a senior citizens discount. So age 65 or older will receive a 25% discount. Alright, so let's look at this in the flowchart form first to get an idea of what it looks like visually, and then we'll convert it into Python. So we start up here at the start. We're going to grab the age, and then we're going to enter our first decision statement. So if age is less than 13, we'll take this path. We'll set discount to 20%. We'll just follow the lines here and print out our discount. Okay, let's come back in again and grab an age, and if the age is greater than 13, we're going to follow this path, and we're going to make another decision. We're going to say, okay, well, is the age greater than or equal to 65? If it is, then we'll assign discount to 25 or 25% to discount, follow the lines, print out the discount and end. If it's not, then we're going to set the discount to 0, follow the lines, print it out, and end. So we're going to fall through this flowchart one way or another. Let's take a look at what this looks like in Python. So same thing up here, we're still grabbing our age, converting it to an int, and we have our if, so if age is less than 13, set discount to this. Elif, so this will only be checked if this condition is false. The only way that this condition is going to be false is if the age is 13 or greater. So if it's 13 or greater, we're going to say, well, is the age greater than or equal to 65? And if it is, discount equals 25%. Lastly, if this is false too, then we're going to jump down to the else block. So the else is like a catch-all in this situation, and we're going to assign 0 to discount. We will converge back here on the same indentation level and print out your discount is whatever it was assigned in one of these three. So looking at some test runs here, if we try an age of 8, we see it falls through that flowchart correctly and we get a discount of 20%. If the age is 70, then we get a discount of 25%. If the age is 13, it's unfortunate, but it's a 0% discount because it's right there on the edge of getting the 20% discount. And we also want to check this 65 because that's right there on the edge too. But if you remember, it was if you were 65 or older. So 65 actually gets the discount. And then some arbitrary number in between these ranges like 24 does not get a discount. So notice the difference there between one case I had a less than where 13 would not get a discount, But in this one, I used a greater than or equal to, so 65 would get a discount as well as anything above it. All right. Lastly, let's talk a little bit about conditional expressions. So, a conditional expression is really just something we call syntactic sugar. Functionally, we can write a conditional expression out of the if-else statement that we've already learned about. However, this is sort of a shortened, compressed way of writing that. So we call it a ternary operation, meaning that there's three operations happening here in one line. And it's good practice to restrict the usage of this to just assignment statements. So let me show you an example, and I think that'll make a lot of sense. So here's the abstract syntax. We have a true expression, if condition, else, a false expression. So we're going to do something if this condition's true, else we're going to do this. So let's look at an example of that. Traditional if else. If the age is less than 13, discount equals 20%, else discount equals 0. We can combine these four lines into one if we use the conditional operator. So the conditional operator here. What comes first is our true expression. So 20%. Discount equals 20% if age is greater than 13. That actually reads really well in the English language, doesn't it? Else, 0. So discount equals 20% if the age is less than 13, else 0. Effectively the exact same thing as what we have written up here. So I don't really care which one you use in your programs. Lots of times this one makes a lot of sense to use when we're dealing with assignments because like we just saw, it's very easy to read. It's easy to understand on just one line. But basically, unless I'm asking you to explicitly do a conditional expression, I don't really care which one of these you decide to go with. This leads us into booleans. Booleans is another data type. And it's a really simple data type. It only equates to one of two things, either true or false. So basically the relational operators that we've been using, like age less than 13, always either equates to true or false, and that data type is a Boolean. So Booleans come from the mathematician George Boole. He's a sort of the father of logic and has a field of mathematics named after him, Boolean algebra. So you'll probably hear about him in some of your math classes. And essentially those relational inequality operators, all of those return Booleans. So we can also talk about Booleans as literals too in our code. Just like how we have string literals and numeric literals, we can write false like this. We can see that it's syntax highlighted to show that it's a keyword. We could also write true. So both of those, when we write them as literals, start with a capital letter. So discount equals false. If we look at the type of discount, so the same way that we inspected types earlier this semester, we can see that this is a bool. So it's a bool data type, meaning it's a Boolean. If I have age equals 8 and I assign discount 2 to be equal to age less than 13, this is sort of proving what I was talking about when I say that these equate down to a Boolean. So age less than 13, if we print that, we see it's true. And if we look at the type of it, it's a Boolean. So these Booleans, we can check them for equality. We have discount, which is false, and we have discount 2, which is true. If we check those for equality, well, does false equal true? No, that's false. One thing we can do with Booleans is we can use operators to chain them together. So there's three operators we're going to go over, and that's and, or, and not. So an and is true when both operands are true. So if I say a sentence, as silly as this might be, if I say that the sky is blue and the grass is green, for the most part, that's going to be a true statement. Unless maybe it's wintertime and we got some brown grass or one of those nice pink sunsets or something like that. Uh, Thinking about an or is true when at least one operand is true. So I could say something like, the sky is blue and the grass is orange. So the grass is orange is a false statement, but the sky is blue is true, therefore the whole sentence that I said was true. And then not is the opposite of a Boolean value. So if we have something that's already false and we not it, then we are negating it, similar to what I was talking about earlier with the exclamation point being a negation symbol. Then it's going to make that false become true. Or if we're dealing with something that's false, it's going to make it become true. So I guess another silly example, the grass is not orange. Okay, so moving on, let's look at another example and try using some of these Boolean operators. So in this example, we want to write a simple tax calculator, and we're going to prompt the user for their total income and then compute their tax rate. The tax rate is computed based on the following. So looking at this table, we have min income of 0, max income of 100,000. That's going, or I'm sorry, 10,000. That's going to be a rate of 10%. $10,001 up to 50,000 will be a rate of 20%. 50,001 up to 75,000 will be 30%, and then anything above 75,000 is going to be 40%. So, think about income. As we're writing this program, we need to input something, right? We're going to get the input from the user. And if we think about income or paychecks, they're typically not whole numbers, right? We get paid in change sometimes, like a certain amount and 32 cents. So we need to take this in as a floating point data type. So I've converted my input to a float and assigned it to income. And then I'm basically checking each one of those ranges. So if 0 is less than or equal to income, and income is less than or equal to 10,000, I know that you fell in this particular category, right? So I'm checking to make sure that you're in between these by using that AND operator. And if so, then I'm going to set your rate to 10%. So rate equals 0.1. Elif, so if this is false, if the income is greater than 10,000 and is less than or equal to 50,000, then the rate equals 0.2. Now what if I didn't have this AND here? If I didn't have the AND here, then 75,000 is greater than 10,000. 100,000 is greater than 10,000. So we have to have the AND there to restrict the range that we're looking at. Because if we're just looking at things greater than 10,000, we're not going to have the correct result here by setting rate to 20%. Okay, so if that's true, we'll set rate to that, and then we'll skip over everything and meet back up here. If not, then if the income is greater than 50,000 and the income is less than or equal to 75,000, set the rate to 30%. Lastly, if all of these were false, hit this else and set the rate to 40%. Now, why did I not check to see if income was greater than 75,000? Well, I could have, but I know that I've already checked to see if it was less than or equal to 0. I'm assuming, which is sometimes wrong to do in a program, that the user would not enter a negative number. So if that's the case, and I'm assuming all I have is positive income, then the only thing possible after not being in these ranges is something has to be greater than 75,000, just based upon the conditions that I'm using. So that's why I just use an else here. And then at the end, I print out your rate is %D. Okay, so %D is for whole numbers, so it's going to sub in an integer here. So it's going to multiply whatever the rate is times 100. And then I put a percent sign behind it. So why are there 2% here? Well, we know when we do string formatting that the percent sign means something. Anything or whatever the character is that follows the percent sign, stands for a certain type of substitution. So similar to how if we want to put a backslash in a print statement, we have to escape it. And if we want to literally put a percent sign in our print, then we'll just do percent percent. And that's going to only print out the percent sign itself. So let's take a look at how this works. I've got this written up in idle, and I'm going to save it and run it. And let's just test it out. Let's say that we're making $5,000 this year. Then our rate's going to be 10%. So we followed through, we got that. It jumped down and did the print. Okay, let's run it again. Okay, so enter your income. Let's try 30,000 this time. And we see that we're in the 20% bracket. So we fell into this range. So we won't exhaustively try them all out. I encourage you to do that on your own and make sure that everything works correctly. But let's try something like 150,000 and we see we're in the 40% tax bracket. So I feel like this the logic is good and this program's working correctly. So moving along, there's another way that we could write this. If we assume that we don't have to worry about like zero, the lower bound, and we take note of the fact that we're sort of falling through here one at a time, essentially we can write our program a little bit simpler like this. So if income is less than or equal to 10,000, then you're in the 10% bracket. Now, something that is sort of implicitly true here is that if this is false, if income is less than or equal to 10,000 is false, then that means income has to be greater than 10,000. So there's no reason to really write it here as a compound condition. We can just say else if income is less than or equal to 50,000 because we already know that it's greater than 10,000 or else we would have entered this body. Okay, so same thing here. If we reach this else if and we're evaluating this condition, then we know for a fact that income has to be greater than $50,000. And then same is true for the else. If we don't do any of these bodies, then the else acts as a catch-all and we get 0.4. Okay, last thing I want to cover here in this lecture is the membership operator. So this determines if a specific value can be found within a container object. So what are some container objects we've learned about? Well, last week we learned about list, tuples, and dictionaries. So those are all containers. They hold other objects within them. And the membership operator is very easy to understand. There's just two keywords, really one keyword, and we can negate it. So we have the keyword in that lets us know if the left operand is inside the right operand, and then we have the negation of that. So if something is not in. So let's look at the abstract syntax here. It's basically value in container. So usually we'll use these in an if statement. So if the value is in container, if Alice is in students, if Alice not in students, so something like that. If student was a list, or students, I mean, was a list. So let's look at a concrete example of that. We have students list. So Alice, Bob, Charles, David, and Eve. And we're going to input for a student. And we'll say that if that student is in students, then print out so-and-so is in the class. Okay, so student gets subbed back in, that student is in the class. Else, print out that student is not in the class. So let's see that in action. So if we try Sally, let's just jump back. Sally's not in this list. We only have Alice through Eve. If we put Sally in, then it's going to say Sally is not in the class. And if we put Bob in, it's going to say Bob is in the class because Bob is in this list. Okay, so we just use this in operator to check for membership. Is this operand, what's on the left hand side, is it an element within this list that's on the right hand side? And as you can imagine, if we put not in, it's just going to negate that. So if this returns true, if we have not in, it'll become false or vice versa. All right, so that's it for our chapter on branching. If you have any questions, please reach out to me. If not, I'll talk to you guys in the next video. Thank you.